Hi everyone. Today I want to talk about quadrilaterals and the hierarchy of these quadrilaterals. If you can hear something in the background that sounds like it's vacuuming, that's Optimus Grime. Yes, I named my robot vacuum Optimus Grime. I'm hilarious. When we talk about quadrilaterals, there's a flow chart, there's a hierarchy. The first is a quadrilateral. And a quadrilateral is any four-sided figure. Quadrilateral. Any four-sided figure. It's a polygon with four sides. It can be irregular. It can have a certain shape to it. But that is kind of like the grandfather of all quadrilaterals. Basically, a quadrilateral. It's where it all starts from. From this point, we go into three separate categories. One category is called a kite. And a kite is what you would imagine. It is a thing that you would kind of fly in the air, right? And a kite has a lot of specific characteristics, but for this particular video, we're just going to say that it has no parallel sides. And a kite is on an island all by itself. It doesn't have any other offspring from it. It's basically a quadrilateral simply and only because it has four sides. Another quadrilateral pair or set that kind of dies after a couple of ones is a trapezoid. And a trapezoid is a quadrilateral with only one pair of parallel sides. Now you have to say to yourself, well, Dr. Dramis, I've seen trapezoids with that look way different than what you drew. And that's true, but those are called a separate set of trapezoids. So a trapezoid is a quadrilateral with one pair of parallel sides. The one that you might be thinking of in your head is called an isosceles trapezoid. That's a terrible drawing. Pretend like these, no, you can't see it. Pretend like those two sides are equal. Sorry. An isosceles trapezoid is basically what I had just drawn. It's still a trapezoid with one pair of parallel sides, but the other sides, the non-parallel sides, they're equal to each other. So I can say that they're equal to each other. And they look similar too. So this is called an isosceles trapezoid. Okay. Now let's go for the good stuff, right? Because after isosceles trapezoid, there's nothing. Nothing happens after that. The good stuff is a quadrilateral goes right into a parallelogram. Mm-hmm. Oh, the cat knocked over the thing. I'm not kidding. Look, there's a cat. Hello, cat. Okay. Parallelogram. Okay? Two pairs of parallel sides. Now, from a parallelogram, we go into two different categories. Rectangles and squares. Okay? Rectangles and squares. Right. So with a rectangle, all four angles are equal because it's a rectangle and they're all 90-degree angles. Opposite sides are equal, okay? And opposite sides are also parallel. A square has all four sides that are equal and all four angles that are also equal. Now, an offshoot of that, which is equally as important as a parallelogram comes to square, is called a rhombus. Now, a rhombus is a really, really, really interesting quadrilateral. It's basically a square that got tipped over. Just like you would say that a parallelogram is a rectangle that was tipped over. Like if I just pushed this corner a little bit to the right, it'd look like a parallelogram. Well, a square and a rhombus have that same characteristics, the same functionality. Okay? A rhombus has all four sides that are equal, and a square has all four sides that are equal and all four angles that are equal. So we're coming up on a 4.5-minute video. But basically, this is the hierarchy that we're going to be discussing tomorrow for quadrilaterals. And then we have some other characteristics that we'll talk about, but this is the basis of it, guys. All right? See ya.